Last lesson in Chapter 2 is scientific notation. So numbers written in scientific notation are of the form a times 10 to the x, where a is a number between 1 and 10, not including 10, and x is a power. A can be positive or negative. X must be an integer. A, for the record, is more often than not going to be a decimal of some sort. So what we're going to do with scientific notation is convert between scientific notation and standard form. So first up is converting from scientific notation to standard form. 2.64 times 10 to the 7th. There's a very simple trick for this. Rewrite the original number, which is 2.64. 10 to the positive 7 basically says take the 7 and say that's the number of times I'm going to move the decimal point. And because it's positive 7, move it in the positive direction, which is right. 1, 2, 3, 4, 5, 6, 7. What do I do with all those holes I made? Fill them in with zeros. Go back and rewrite your new number, filling in the commas where appropriate. This is something, the commas, I don't normally worry about because more often than not, the biggest numbers we get are like 4-digit, and I don't really worry about the comma there. But with scientific notation, we are going to get numbers in the millions and possibly billions. Commas are very helpful because they help break the number up. It makes it much easier for me to look at what you've written. So please take the extra line and write out the number. 1.35 times 10 to the negative 4. So we know we're moving the decimal point 4 times because the exponent is a 4. Since it's negative, we're going to move it in the negative direction, which is left. So that's this way. So 1, 2, 3, 4. Again, fill in your holes with zeros. So this is 0.000135. Negative 5.8 times 10 to the 6th. Well, we take our negative 5.8 and we move right 6 times. 1, 2, 3, 4, 5, 6. Fill in our zeros. Rewrite our number. And backfill all of our commas for negative 5,800,000. So going to standard form, pretty easy. It's just moving a decimal point. Getting scientific notation is equally easy. It's moving a decimal point. But it's a smidgen trickier as well. So here's the rule for moving the decimal point. I'm going to grab it, I'm going to move it until there's only one number that isn't 0 on the left side of it. So in this first example, I'm going to have to move it to the right 1, 2, 3, 4, 5, 6, 7 times so that I can have something that isn't 0 on the left side of it. The thing on the left side is 2. There's nothing after the 2, so this is going to be 2 times 10 to a power. Now this is where it's a little bit squirrely. When going from standard form to scientific notation, the direction you move is the opposite of the sign of the exponent. Normally we would say if I move to the right that I'm going to the positive side. Here, because I went to the right, my exponent is negative. This is actually 2 times 10 to the negative 7. And you can always check yourself in a pretty simple way. If the number you start with is a decimal, a small decimal, you should have a negative exponent. If it's a big number, you should have a positive exponent. If it was already a decimal, we'll deal with that at the end. Next up, we have 75 million. So the first question is, where's the decimal point in 75 million that I'm going to move around? And the answer is that it's at the end. Whole numbers have an invisible decimal point on the right end. Now I've got to move this thing all the way to the left until there's only one number that isn't 0 on the left side of it. Right now there are two numbers to the left of it, 7 and 5. The zeros don't really count. So we're going to move it 1, 2, 3, 4, 5, 6. If I move it 6 times, there's still 7 and 5 on the left side of it, and that's not okay. So I have to move it a 7th time so that only 7 is on the left side. 7 is on the left side of the decimal point, 5 is on the right side of the decimal point, so that's 7.5. We move the decimal point 7 times, so it's going to be 10 to the 7th. And since we moved the decimal point to the left, it's actually a positive 7. Remember, standard form to scientific notation does the reverse of what you think. When you have to move the decimal point right, it's negative. When you move it left, it's positive. On 565, our decimal point is on the end, and there are 3 numbers to the left of it, 5, 6, and 5. You're only allowed to have 1. So I've got to move this decimal point 1, 2 times so that I've got 5 on the left side and 6, 5 on the right side, 5.65. We move the decimal point 2 times to the left, so it's 5.65 times 10 to the positive 2. And my last example here. The decimal point is there, you can see it. The problem is there are 2 numbers on the left side of it. You're not allowed to have 2 numbers, you're only allowed to have 1. Which means we've got to move that decimal point left 1 place. That puts my 2 on the left side. Now I have 3, 4, 5, and 8 on the right side. Times 10 to the first power. We move the decimal point left once. Left here is positive, and 1 time is 1.